Greetings everyone, I'm Petrovic, a teaching assistant at Faculty of Electronic Engineering, University of Niš in Serbia, Department of Computer Science. In what follows, I will present you my paper entitled Digital Consumption as Art Expression, Ontological Approach to Vaporwave Generation. In the early 2010s, a novel digital consumer culture-inspired audiovisual style has emerged over the internet, known to the audience as Vaporwave. Its musical and visual form is quite distinct, unlike anything you have ever seen before. When it comes to musical form, it consists of loops extracted from 80s and early 90s contemporary and background music tracks, such as mood jazz, corporate jingles, call center hall music, and elevator music. Moreover, the tracks are not only extracted, but they are filtered and slowed down. The vocals are rarely present, but when they are present, they are pitched down. The overall structure is quite repetitive. We have just several loops that are repeated over and over again. The tracks are overly short in most cases, they last less than 1 minute. When it comes to visual elements, we have extracts from VHS tapes, from TV adverts of the same era, 80s and 90s. When it comes to topics present within these adverts, we have electronic consumer devices and entertainment devices, such as video game consoles. Moreover, corporate lifestyle, luxury cars, tropical locations, fashion products, shopping malls, classic statues, and even soft drinks. Apart from that, motifs from early 90s personal computer and internet era are also present, like primitive low-poly 3D graphics, Windows 95 interface and application, desktop application elements, internet browsers like Internet Explorer, and primitive web applications, and so on. I'm also a Vaporwave artist since the earliest days of this style, and I'm performing under the name New Vision Score. In what follows, I will shortly introduce you to one of my works in this style, to give you a more complete overview of what I'm talking about actually. As you can see here, we have low-poly 3D models that are rotating. We have Windows 95 logo, tropical location. So actually some repetitive down-tempo whole center whole music inspired track. This is what makes Vaporwave in short. When it comes to philosophical interpretation of Vaporwave, there are several different opinions. I extracted four most mentioned opinions. The first one says that it's a satire of consumer culture and modern capitalism. Actually, it comes from Karl Marx's Communist Manifesto, especially the statement, all that is solid melts into air. So we have a bunch of once solid commercial tracks, high budget tracks created in 80s and 90s. They're taken, they're sampled and, to say, vaporized into a single Vaporwave track. They lose their original form, they melt into just one distinct song. So this is actually how Karl Marx's statement is actually being transferred to domain of Vaporwave music creation. Moreover, we have very often nostalgia for past futures. What actually means? So based on term vaporware, that refers to products and technologies that were advertised in past to the public but were never manufactured or released. Actually, the first part of Vaporwave comes from this, when it comes to the term. So how is it related to perception of Vaporwave? Like, we have motifs from past that remind us of something that was promised in past, something that we expected to happen, but something that never happened actually. So we have some kind of distant, false nostalgia for something that never happened. The third approach says that it's punk of post-internet era, something that was created as a result of rebel against the copyright laws and policies that emerged. So internet era has brought chaotic situation when it comes to copyrights and when it comes to creative work and licenses. So it's somehow some kind of expression, a rebellion against that. Moreover, finally, we have embodiment of the digital consumption process itself as a motivation of Vaporwave. So the artistic product is built upon others' work, upon other samples, 3D objects, and the producer is actually a consumer himself. So the art is created in iteration of production and consumption. So one product of creation can be input for another iteration for new products. So it's actually the digital consumption process itself. Now let's see what is actually the goal of the technological part of this paper. When it comes to goal, we can say that actually it has goal to enable convenient, rapid generation of vaporwave content from predefined elements, and moreover, to enable performance of vaporwave tracks that were generated this way. As outcome, I propose a semantic-driven, ontology-based framework for rapid automated vaporwave art, audiovisual art creation. It enables convenient generation using modeling tools without too much effort by the user himself. The generated application that is created as a result of transferring semantic ontological representation of vaporwave art to an application has two distinct parts. The first part is augmented reality part, and it serves as music interface for vaporwave track performance by loop mixing that is done by a music performer, by the producer. On the other side, we have virtual reality for visual representation of the 3D worlds that are shown to the audience. Two types of generation are actually used in this paper. We have completely user-defined approach where user specifies all the elements that he wants to see within the generated result. And moreover, we also have random approach that randomly combines different loops and 3D objects. When it comes to related work, one of the most significant works in this area is programmatic approach to generation of vaporwave tracks by random combination of loops that were extracted using beat detection and applying reverb afterwards. The author used a Python programming language for this. Moreover, we have one related work that comes to, which is related to actually visual representation of vaporwave songs in virtual reality, and also rave tracks in Venus paper, but here we only stick to vaporwave. Third and fourth paper actually part of my work. In the first one of these two, we used ontology-based approach to generate augmented reality applications that were Unity 3D applications, and in the second one, that is ontology-based 3D world generation approach, we used ontologies to generate Three.js applications that show interactive 3D worlds in web browser. Now let's see the background of technical part of this paper. We have ontologies and semantic web technology. So ontology refers to a philosophical branch that is studying the ways of being and relations between them. In the domain of computer science, ontology is a conceptualization of a particular domain. Each ontology consists of classes, individuals, relations between them, and their attributes and properties. Collections of facts that are actually stored with respect to the definition of the ontology are stored within the semantic knowledge base. We use 3DF or RDF format in order to store semantic representations of vaporwave arts. Moreover, Spark query language is used to query the semantic knowledge base where our RDF format facts are stored. So RDF is used for both the ontology and the semantic knowledge base. On the other side, we have web-based augmented and virtual reality frameworks. When it comes to augmented reality, I use AR.js framework that enables high performance on low power devices that are like 5 years old, and you can still get like 60 frames per second. And it's very convenient to use like just 10 lines of code to perform to create complete augmented reality applications. And on the other side, I used Three.js, that is a WebGL-based framework for rendering interactive 3D worlds in web browser, but is a bit higher level than the base of the framework. So I can conveniently load 3D models and perform animations without going too much deep into details with low-level graphics. Also, it enables convenient transfer of 3D applications to virtual reality. Now let's see how the framework is structured. First, the user creates an application model, actually the art model, in a modeling tool. It's stored in a semantic knowledge base with respect to Vaporwave generator ontology. Code generator executes queries to take the parameters from the semantic knowledge base during the code generation, and as a final result of code generation, we get HTML page that uses AR.js and VR code in Three.js. Actually, it's a JavaScript code that is embedded into HTML page. Vaporwave generator ontology. This is a domain ontology that is used to semantically represent Vaporwave art content. However, I used some mappings between the input and the output to specify the interaction of user on one side and what actually the audience will see when some event happens on the performance side. So we can imagine Vaporwave art, actually the Vaporwave generator application, like mapping of input and output, a set of mappings. When it comes to inputs, we have several methods like key press. We have time events like after several seconds, execute, show this 3D model, play this sound, and so on. And finally, we have markers, augmented reality markers like barcode markers and QR codes and custom markers that are used to trigger generation of some output. When it comes to output, there are two types of output, sound and 3D model. When it comes to sounds, they can be processed by some effects. I use MATLAB for sound processing. These processes for sound modification are pitch down, speed down, and filtering, low pass or high pass. Each sound, each loop actually, has its key that is used in order to ensure that generated product or Vaporwave art will be musically correct. Moreover, we have 3D models. These 3D models can be either environments like tropical island, shopping mall. It's actually a container, a set of objects that are connected in some logical way that represent 3D environment. Inside this container, we can place other objects like palm trees, dolphins, cars, arcade machines, drink cans, and so on. And finally, these objects can have some animations like rotation or some custom movement within the environment. Application modeling environment. Application modeling environment is based completely on Node-RED that is run in web browser. User here has to specify the Vaporwave art that he wants to generate. Actually, it's used to specify the properties of AR and VR application. When it comes to AR application, we specify inputs like markers. You can see on this slide, I present you a model with three inputs, three markers, three numeric markers, barcode markers, and each of these markers has two outputs assigned. A distinct sound and a distinct 3D object that is shown when this sound is played. And also I applied, for example, on sound loop 1, I applied speed down by 25% and VHS low pass filter. Underlying algorithms. I used two algorithms in this paper. The first one transfers the semantic representation with respect to Vaporwave generator ontology of Vaporwave art to VR and AR application. So in the first step, we retrieve all the pairs of inputs and outputs from the application, open event handler for each of these inputs, and retrieve all the outputs for a given input. Moreover, depending on the type of output, a corresponding action is taken, like loading 3D model or animating it, rotating it if it has to be animated. Moreover, for sounds, we check if it has to be processed, apply MATLAB filters, and then we load and play the sound. Actually generate the code that will play the sound when input happens. So after that, after we traverse all input-output pairs, we generate the complete AR.js and Three.js code application. On the other side, we have a randomization algorithm that generates Vaporwave art randomly, leveraging the knowledge stored within the semantic knowledge base. However, there are several constraints that are given by the user himself, the number of transitions actually, number of objects within each transition, and the key, the desired song key, to ensure that the generator track will be actually musically correct. The output is semantic representation of vaporwave art. So when we, for example, call the second algorithm on the right side of the slide, this can be used for input of the left algorithm that will generate two corresponding applications. So when we want to generate randomly a vaporwave piece, we provide a key, retrieve the sounds from semantic knowledge base where sound key has the desired value. After that, for each of the transitions, we add a random sound from the set of actually taken sounds randomly. And moreover, we take n objects, random objects from semantic knowledge base and add to the scene. So this is used later for as an input of the left algorithm. The generated system for Vaporwave art performance is shown on this slide. We have performer who uses a paper where printed markers are present, and he just moves hand around to whether play or stop the corresponding loop. So to each marker we have loops assigned. We have AR application that sends the generated movement, when some marker is hidden or shown, the event is generated, sent to Node.js server that actually triggers showing some 3D model within the VR Three.js application and playing corresponding sounds on the part that is shown to the audience. Now let's see evaluation. A laptop with given characteristics was used for evaluation, and I evaluated the code generation time for reconstruction of my two tracks, Arcade Hero and Virtual Instancing. In Arcade Hero, I had 5 loops and 5 3D objects, and code generation time is quite short. You can see around 3.5 seconds. And for Virtual Instancing, I had 7 loops and 7 objects, a bit longer time. So we can see as long as we increase the number of loops and 3D objects, also the generation time will increase. Moreover, I compared the generated AR music interface for performance against Akai MPX8 commercial sampler, a physical product, and it was around 7 times faster for loop loading and much more convenient. But this product actually costs around 100 euros. So using a piece of paper and something that we have always with us, like a mobile phone or a laptop, is much more convenient than some distinct hardware that is quite slow. Conclusion. The proposed framework uses ontological approach to generation and performance of vaporwave art, and gives ability to both vaporwave artists, existing artists, and consumers that like to listen to this music to easily, intuitively create new vaporwave art, either randomly or by using some specification with respect to given ontology. However, no additional costs for buying some additional hardware, large hardware, are needed, like samplers, like USB controllers, MIDI controllers, and so on. Neither VR glasses of a certain brand or required Google Cardboard can be used on mobile phone to have a full VR experience. In future, however, it is planned to perform subjective evaluation, human-based evaluation of randomly generated artistic creations by the audience and compare it against human-made art in this style, and see how actually the Vaporwave audience likes these tracks that were generated by my framework. Now let's proceed to questions and answers. So the question is, can you talk a bit about interesting use cases which could be achieved with this technology? So we are all witnessing the current COVID-19 pandemic crisis. During this crisis, most of music events around the world were cancelled. Huge losses were made to both organizers and music artists themselves. So this technology, if we refer to the architecture of AR application for music performer and VR applications for the audience, can be used to perform actually any kind of electronic music remotely without physical interaction of audience and physical interaction with the performer himself. So everyone can stay safe even in these difficult times and perform his music using internet. Moreover, I said it can be used for any electronic music style. So we just use different assets and we can get some different results. Thank you for your attention. This work has been supported by the Ministry of Education, Science and Technological Development of the Republic of Serbia.